sklearn.datasets, we'll do import load
Ma'am,
iris.
are you showing
Okay.
something on the screen?
I hope you're all. So let's say we name the
Ma'am, are you showing something on the screen? There's nothing shared.
Hello, good afternoon, everyone. So we'll start in another 2 or 3 minutes. Okay, just waiting for a few more people to join. Uh, at 4:05, we'll start.
All right, thank you.
Okay, so good evening, everyone. Welcome to this live session on programming concepts using Java course, the second session of the course. So has everyone been able to go through the lectures? Like last time, I think many of you did, but I just wanted to check how many more people were able to go through. And if you have any questions to start off, we can take that. And anything to discuss, anything to suggest, anything to ask? Okay. So I guess nobody has any questions. So can I just get a count of how many people have watched all the 6 lectures of week 1? Okay, nice, good numbers. Okay, yeah, thanks. Okay, you can lower your hands. Thanks. So, so there was one thing that probably we did not discuss last time, which is the call by value and call by reference. So is everyone comfortable with that, or do you want me to explain that? If anybody, if everyone is comfortable, I guess there is no point spending time on it. But if someone needs help on it, no, maybe we can just start off with that. Does anyone need inputs on? I mean, does anyone wants to know about call by value and call by reference? No one? Okay, see Sachin, so we are not talking about how to implement it in Java. How we are going to do it is like what does it mean in general? And when you learn Java, you will understand more about how it is handled in Java. So next week onwards is when we are going to start more specific things about Java. So for now, we'll be explaining it in theory as to how it is happening. So maybe I'll just give one example. And so would that help? Maybe not very specific to Java, but in general, like, what does it mean? Is that required? Okay, thanks. Okay, so then we'll start off with that. Okay, give me a second. Let me just share the screen. Okay. Is the screen visible?
Yes, ma'am.
Yeah. Okay. My pen. Just one second. Let me get my pen. There's some issue with the writing pen. Just give me a second. I guess it's visible now. Okay. So we have call by value, call by reference, right? So what is, so bear with my handwriting. It's been a long time since, we have all written on paper and pen, right? So yeah. So, okay. So let us just try an example. Okay. So you have same main function, okay, which is calling another function. Say, so definitely call is nothing but a function call. Okay. So you are calling, say, you want to find the double of a number. Okay. Now you're finding, say, b equal to double. Okay, I'm just putting double. This is my method name. Where a is, say, int a equal to. Now my function double is here, and it is taking some parameter int x. So this will have, say, an int y equal to times x, and return y. So this will be something like that. So this is how the functions look like. Now you look at the activation record. I hope you all remember about the activation record. So what happens when there is a function, when main is being executed, it is actually put into activation record. So here you have the variables, say, a and b. Okay. Now once the function call goes to this DBL, this activation record is pushed in. Sorry, this activation record of the double method, right? Double function, that is actually pushed into the stack, and then you have variables, say, x and y here, right? Now, what happens when you want to call the function double of a, right? This value is actually copied into this memory location. So wherever x is pointing to that memory location, this value is getting copied to. So some memory location, whatever is the value in a, that is actually getting copied to the value of x. So when you do the b equal to double of a, and you are, sorry, when you do y equal to 2 times x and return y, b gets the double value, but the value of a does not change because you are copied. Now x is pointing to one memory location, a is pointing to another memory location, right? So a has value, say, 2, and x got the value 2. One second. So x equal, this will convey better. Okay. Sorry, this is just to explain the things. Ideally, you would do y equal to 2. Now you have updated x equal to 2 times x. Now what happens? X value gets updated by 4, right? What happens in the case of call by reference? To show call by reference, I'm going to use the example of an array instead of a pointer or anything which many people may not be aware of. Okay. So what I'm going to use is, say you have a function, say main, and then you have, say, an array of numbers, which is equal to, say, 1, 2, 3, 4. And then you have, say, b equal to double of 8. And then your function is actually returning an int array. I'm all using symbolic notations in, I'm not using the syntax of any language. So double of int of x, right? And then I'm going to double each value in x. That is what is going to happen. Now what happens in the stack and activation record? Here you have the activation record of main. And here you have the activation record of double, right? Here, the A is now containing the memory location of an array and not a single memory location. Okay, so this is actually going to, A is now going to point to a, this is going to be a memory address, not the value 2. Because A is an array, and A cannot contain, like, 1, 2, 3, 4, 5, 6, all these values cannot be allocated in this location. So this will eventually point to another memory address. Sorry. This is going to point to another memory location. CMA is pointing to an array, which will contain the 1, 2, 3, 4 values. Okay. Now, what are you going to do when you're actually saying int of, you're calling this to this, right? You are copying this memory address here. A is now pointing to memory location. You're copying the content of A to X. So eventually X is also going to contain this memory location, which is again going to point to the same memory location. What happens when you double each value in X? Each value in A is also getting doubled because now both of them are pointing to the same memory location. Do you get this, Sachin?
Yes, ma'am. Now, but in that case, how do we make call by value using arrays? Like what we did here was using arrays, we did call by reference. But on the flip side, how do we do call by value on arrays?
So see, what we do, something like, if you want to copy something like this, generally there is something called copy constructor, deep copying and all that, shallow copying, deep copying difference, right? That we will explain to you when it comes in detail in Java.
Okay.
Ma'am, I have the same question.
Yeah. So this is not just with array, but also with other objects also. Like this is when a single basic integer type, no, then it can be accommodated here. When you want to have a whole employee object or some object, then also the same thing can happen. Not just for an array, I just demonstrated using an array. Yeah. Yeah, somebody else is asking me.
And ma'am, is it possible to call a variable by reference?
In Java?
Yeah.
In Java, no, I don't think there is a pointer reference to a variable unless you have it inside an object or something. You mean a basic data type variable, something like an int or something, no? Yes, that's what you mean, right?
Yeah.
Yeah. So I don't think there is a way to do that.
Okay.
Ma'am, can I ask a question?
Yeah.
So the determination of call by value or call by reference depends on the variable type?
No, not necessary. See, it depends on the programming language actually. See, in C, C++, etc., right? You have this concept of pointers, no? So even variables can be referred like, you can simply have an int star. I forgot my C++ long time back. So you use a star, then it is actually, A will have the memory address only. Even here, it will only be memory address, right?
Right. So
it depends on the programming language. Yeah.
So in these two examples, you're saying B is equal to function double and the parameter A.
Yeah.
How do you differentiate that one of them is value, one of them is reference?
So that's what I'm saying. So the basic, for your understanding, I have taken where in general, the basic data types are as values and these kind of objects, right, which cannot be stored in a single memory location because the size is not. So you're saying this an array is going to be of this size. You have not even given what is the size of array going to be, right? So you cannot definitely store it directly in the directly inside A. You have to have somewhere where it can grow. So you're only giving a pointer where it can expand. The array size can be expanded, right?
Okay.
So I just gave an example where this has to be necessarily done using a point reference. But if you know that the size of the array is same, then probably you can have something constant. But here, when this is an array whose size is not fixed, then definitely this has to be a pointer reference.
Okay, and ma'am, one last bit. If the
Yeah.
function was not to double each value, suppose it was to return x of the highest value.
Huh.
Okay, so b is an integer. In the second, in call by reference, if b is an integer,
Huh.
constructor changes to int and not an array for
Okay,
double,
okay.
then it will not.
Yeah.
Then it cannot be reference.
Yeah. See, I am just giving an example where this
How
actually
will
works.
So will the function internally still update the array and return an integer?
If the function makes a value, I mean, change in value of this x, then it will make change in value of a. That's all. If it can compute the value b without changing the value of x in some way, then it does not reflect.
Okay,
All
so
I'm
x-
trying to say is that whatever changes made in x will be made in a also,
Okay,
because
got
they are
it.
pointing to the same memory location.
Okay, thank you, ma'am.
Anyone else? Okay. Okay, so this is something I missed out last time, so I thought I'll just mention it here. Now I will actually discuss the activity questions. Just give me a second. Share the- Yeah. So here I want some of you to start answering because these are like very simple questions which anybody should be able to answer if you've just watched the lectures. So can you just give me answers, or if you have any confusion, like should I call out names like your profs do at college, or does anybody want to volunteer? No? Okay, so fine. Which of the following statements is or are true? Yeah. Nivedita, please. Yeah. Nivedita, you have raised your hand. You want to ask something, say something?
No, ma'am, I wanted to give the answer.
Yeah, please. Yeah.
So for the first question, it's option B and C.
Programming language is used to provide computational instructions, correct? The program written in high-level program language is directly executed. Sorry, B and
C.
C, correct. Yeah, right. That's correct. So why is D not correct? What did we discuss last time? Why is D not correct?
Because we need a compiler and interpreter.
Yeah, why do we need that? I mean, I am not, see,
To convert it into bytecode, probably.
See, we have not discussed Java at all. So why do you say bytecode? What is it actually at the end? I mean, bytecode is an intermediate code, right? For any, what is it that the machine actually executes? Inside CPU, what is it being executed?
Binary signal.
Correct. Binary code, machine code or binary code, right? So zeros and ones, sequence of zeros and ones, right?
Yes, ma'am.
Yeah. So any high-level programming language, right? It cannot be understood by the computer. It can only understand the on-off states of the semiconductor devices constituting the registers of the CPU, right? So whatever it understands from that will actually. So these are all like how to. There are a standard set of instructions for every CPU, and these instructions are sometimes hardwired in the sense that if it's a sequence of 001011101010, then you have to add two values in two registers which are understood to the machine. Something like there is a register A, B, C, D, etc. Then by default, it has to take the content of register A and the register B and then add it. Something like a sequence of binary, is a definite sequence of binary values which are predetermined by predefined by the computer architecture, right? So this binary code, the conversion to that. So when we say add, in the when we put the plus symbol, right, what the compiler does, it translates to that sequence of machine code which is understood by the underlying computer architecture. So in one particular architecture, it might be a different sequence. In another architecture, it could be a totally different sequence. So depending on the computer architecture is, that's why we say, okay, then we come to this Java platform, independence, dependence, everything. So ultimately, it's the underlying architecture that decides to what set of instructions should this be converted into. So for C, if you see for different platforms, you have different C compilers, right? So the source code is all the same, but to the set of computer instructions to which it has to be converted to, which is understandable by that particular computer architecture, is decided by that compiler. So that's why in the case of Java, we say there is an intermediate form, which is the same for all computer architecture. And then the bytecode, this intermediate layer is called the bytecode, and then this is converted to what is known as a machine code. So bytecode to machine code conversion happens in the runtime environment, which is again running at the client side. And at the client side, it decides, okay, this is the computer architecture, and this bytecode has to be converted to the machine code. So that's a difference between Java and other languages in general. There is an intermediate step, the high-level programming, the high-level code, then the bytecode or the object code, and then comes the machine code or the binary code. Okay, so definitely the high-level programming language has to be converted to the machine code for the machine to execute it. Okay. So, yeah. So I'll move on to the next. Anybody has any questions? Okay, like this. Okay. Which of the following statements? So Nivedita, you want to go, or someone else? You want to go for the next question?
Yes, ma'am.
Yeah. No, if you don't want to, totally free. Okay, I mean, just because you volunteered for one, I'm not picking or anything. Okay. Yeah.
Okay,
Feel
ma'am.
free
So
to. Yeah.
I can leave.
Sorry.
I can go ahead or I can leave.
No, you can go ahead. Yeah, please.
Okay. It's option A and B.
A variable is a name which identifies a memory location. Yes. A variable is a symbolic representation of the memory location. Yes. A variable value cannot be changed once it is initialized. Yeah. So in general, this is not true, but in certain cases, you can declare, you can give a modifier or access modifier just in front of a prefix, in front of a variable name, and say that once it is initialized, it cannot be changed. That is possible in certain cases, but this is not true in general. And hence, this is not a correct option. A variable should be initialized during declaration, which is not true in all the cases. Okay. Yeah. Yeah. Thanks, Niveda. You want to go ahead with the next one also?
Yes, ma'am.
Yeah, please.
It's option B and D.
An interpreter. So 1 second. A compiler converts a program in low level, which is clearly program in low level to high level. No, which is not correct. An interpreter converts a program in high level program to code in low level language, instruction by instruction, which is correct, right? We discussed this last time also, right? The difference between Java and Python. No? Certain programs compile the whole code into machine code and then execute the instructions one by one. Whereas here it is actually one instruction is converted into machine code and then executed it, and then you go for it, etc., right? Okay. An interpreter converts low-level machine language, which is not correct. A compiler and an interpreter convert code in high-level programming language, which is correct. Okay, great. Yeah. Consider, yeah. Nivedita, yes. You want to try this? Or
Yes, ma'am. Option B.
declarative programming approach, right?
Yes, ma'am. Recursive function.
Yeah, so this is almost the same example, that not the same example. Sir has given a sum of a list of numbers, I guess. Here we are given the example of a factorial. So wherever recursion is there. So somebody had asked me about an example, declarative programming in Python. I remember somebody had asked me last time. So I went and checked, and I guess there are certain, there are certain articles on it where they are referring to, certain methods in the NumPy and the TensorFlow and all that. I was not able to follow it. I mean, I did not get time enough to explore much. But if you could just read that article, I think it's not, I wouldn't say that except recursion. So whoever was asking me was asking about a case other than the recursion cases, right? So apparently these packages like NumPy and all that, where instead of a loop, it actually goes for some very simple functions and all that. So please check that out. I guess I had the link somewhere. Maybe I'll just share in the discourse. I'm sorry if I forgot to update it. Okay, so
Option A.
option, sorry.
A. A.
Yeah. This one?
Option B.
Correct. Okay. So registers are present in memory. Is it correct or wrong?
Yes, but they allow computation.
Then the last case is correct, no? They are present in both memory and CPU and allow computation, right?
Yes.
So see, registers are something like fast accessible memory locations, or this is like locations of where the data can be added. These are like really fast locations. So these are present only inside CPU. As compared to the main memory or the secondary memory, right? These are easily accessible for the CPU and they are really fast because most of them have hardwired function. Hardwired functions are in general much faster. Okay, so these registers are present inside the CPU only. The other things, whatever are the memory locations which are present, we call them as simple memory locations. Registers are like high-speed memory locations which are present only inside the CPU. Okay. Okay. So which programming style may store intermediate? So see, for this is a slightly confusing questions, and both in imperative and declarative, you may have intermediate values. But in general, what the essence of this question is that in the case of declarative, you are not saying, okay, you store this intermediate value here, you store this intermediate value here, you store this intermediate value here, right? So what you're generally saying is that you are only indicating what you want, not clearly specifying how to get it, right? That's all what is intended by this question. Okay. So which programmer may store intermediate ones? So I will just go with imperative style. Okay, fine. Go to the activity 1.2. Can someone else volunteer? I think Nivedita asked. Okay, I have already checked the answers, I guess. Okay. Okay. Probably somebody can explain the answers, right? Just 1 second. Yeah. Can someone tell me which of the following statements? Okay, it's already given. The answer is given. There was no point explaining it. Okay. So we discussed last time the difference between the static typing and dynamic typing, right? So in static typing, we declare the variable before it is being used. This ensures that the value that is being assigned to the variable is of a certain type alone, and that we are not accidentally declaring variables which are not intended, as shown in the example that sir had given. If there is a typo in a variable in programming languages which follow dynamic typing, it is easy to miss out such typos and errors because the compiler or the interpreter would naturally assume that this is a variable that was intended by the programmer. It will assume that the programmer will take responsibility for coming up with the right variable and ensuring that there are no typos and all that. So static typing, the advantage is the programmer will definitely know at least if there are variables that he or she had not intended to declare. So that's what. So bugs are caught early because type of variable is declared in advance. So the following statements are correct about dynamic typing. Okay, it is convenient because type of a variable. Yeah. So in Python, I think many people like this one particular feature of Python that you don't have to declare variable. You can straight away start using it most of the cases. So yeah, and again it comes with the disadvantage that the type errors will not be detected during compile time, and that will be detected only during the runtime, right? Which of the following features are incorrect about static types? Okay, it helps compilers to catch bugs early. We've just seen that. Making sense of arbitrary bit sequence in memory. So this is for any typing, right? Why do we have types? We have types because, as I said, like these memory locations have data which are binary code, zeros and ones. To make sense of what one particular sequence of data is standing for, we actually say that, okay, this particular sequence can only represent an integer, it can represent only a string, it can represent only a float. So to make sense of a bit sequence in the memory, we attach types. So whether it is with respect to static or dynamic typing, this is true. Makes a compiler run faster. Okay, so Static typing clearly when during the compilation, the compiler will allocate memory and it will allocate and it will ensure that the processing that it takes to verify the assignment or the compiler during the compilation, the time that it takes for the compiler to verify that the type is correct for a variable, that takes time, and hence it kind of makes the compiler slow in generating the machine code. Okay, so generally the compiler will not be faster in the case of static typing. Organizing concepts in code in a meaningful way. So clearly when you see a variable, you can always, when you have started using a variable. So even in Python, we quite often type this, type of A, type of B variable, just to check that what is the runtime type of that variable, right? But in the case of Java and all that, you don't do it because you clearly declare, okay, and say that, okay, this is the value, this is the type of this variable, and we don't necessarily need to do this type of thing in Java, right? So this is about organizing the concepts, like yeah, I hope you understand what it means by organizing the concepts. I don't think it needs any more explanation. Which of the following statements are correct regarding the variable declaration? Variable declaration will result in an error during type checking at the compile time. Yeah, okay. So this is about the static typing, right? So it may result in an error. I hope I have checked the correct answers. Let me just. Yeah, okay. Variable declaration is a waste of effort. Clearly, no. Variable declaration. Okay, you may say it's like that. I don't know how many people disagree with this. It's a waste of effort. Is it indeed a waste of effort? People who are passionate about Python, may beg to differ on the statement. Does anybody think variable declaration is a waste of effort? I'm open to arguments, no confusions. You can tell me if you think so, we can debate. Anybody feels variable declaration is a waste of effort?
No, not waste of effort. I think.
Sorry?
I think it is not waste of effort.
Okay. Yeah. So this part is clearly wrong. So probably even if you think this is correct, this part like increases the cost by throwing errors at early stage, which is not correct. If you are able to catch errors early on, that will definitely reduce the cost. Okay? Variable declaration is a property of dynamically typed programming language. Not always. Variable declaration is a property of statically typed. Yes. In all statically typed programming languages, variables are declared well in advance. Before they are used. How to check? Yeah, so this question had caused a lot of confusion. Many people. Is it clear for everyone, or does anyone still have a doubt about this? How to check whether a given program halts? Does anyone have any doubt?
Ma'am, I have a doubt. Like, will you explain the concept of dynamic lookup once again?
Dynamic lookup, huh?
Yeah.
Yeah, I'll come to that. But before that, shall we just finish these activity questions? I was asking about this question.
Okay.
I will explain that dynamic lookup. I will explain it. But before that, do you have any doubts in this?
No, ma'am, it's clear.
So let me just go to that. Let's just finish this AQ questions. Okay, then I'll come to your doubts. Okay, is that okay?
Okay, ma'am.
Okay. Yeah. The concepts of scope and lifetime. So was that clear for everyone the last live session, or are there anybody here who still has doubt about it, like scope and lifetime of variables? Anybody? Okay. Okay, I'm assuming everyone knows. Return value link tells where to store the result. That's correct. Automatic garbage collection cleans of stack memory. Is this true or false?
It should be false.
So what memory does it clean up?
Heap memory.
Correct. Correct. Which of the following statements is correct? Call by value has side effects because it copies the value. Function parameters cannot be initialized using call by reference. Call by reference has side effects because parameters and arguments refers to different memory locations. Call by reference has side effects because parameters and arguments refers to same memory location. Anybody wants to answer this question? And tell me why. So I've just explained what
The last
call by
one.
value and call by reference is, right? Yeah.
Last option is correct.
The last option.
Yeah. Why?
Because ma'am, it will be pointing to the same memory location. That means it can change the original data.
So why do you say it is a side effect? Because it is an unintended effect, right? When you are transferring something to X, then you assume that you are only transferring. So yeah, there is your assumption which is getting, that's what is meant by the side effect here, right? When you are transferring the value, I mean, when you are saying, okay, I'm calling with respect to A, you are assuming that the whatever changes happen there will not affect the value which is being passed as an argument, right? You will assume that the argument will remain the same, only whatever are the intended effects will be returned to the value where it is actually receiving the value, right? Only those, that is where we expect to change the result. So we expect to find the result, okay? Find the change. Whereas in this case, you actually see that the value that is actually going in as a parameter or the argument itself gets changed, which is an undesirable side effect. That's why we say call it as a side effect. Okay, so that's the point of this. Okay, so that's what is meant by this point. Call by value is side effects because it copies the value. There are no side effects. It actually behaves as expected. Function parameters cannot be initialized using call by reference. This is just not correct. All active variables. So active variables are nothing but the variables which are still in their lifetime. Okay. So which is the correct answer in this one? Fifth one. Anybody knows?
The option
C.
C, correct. Okay. So why is that so? Anybody wants to explain?
We saw the example of the Python code where where we could see that x is a variable using the loop for function x, and the similar function can be so similar x variable can be used in function as function g, and it could be that the function when g of x is active, for example, it could not be in the scope of function f, but you get it, right? My point.
Correct. Yeah. So the calling function, right? The main function or wherever, the variable is still active, but that variable cannot be accessed from inside the called functions, right? Whatever are the functions being called, from inside those functions, you cannot actually refer to the variables which are inside the main function, right? So the variables inside the main function is still active, but they cannot be accessed. So that is why they are not in scope. Okay.
is like all the variables in the activation record like is active, but the only the last activation record, the variables in the last activation record are in scope.
Correct. That's correct. Yes. The top of the stack, right? Okay. However you assume the whichever are the latest activation record, whichever is the latest activation record, whatever variables are inside there, those are the only ones which are accessible and in scope, right? Okay. How does a memory space get allocated during runtime? So during runtime, it's a heap memory which is getting dynamically allocated, right?
Yes.
Because depending on the size of the data, if it's an array or an object or whatever, the size of the memory that has to be allocated during the calling, whichever object is being called, whichever during runtime, whichever object is being invoked, depending on that, memory gets allocated in the heap. Okay. Any doubts on that? Controlling points the parent activation record, right? Is it correct? Or is it the child activation record?
Parent one.
Oh, because this is where you want to come back to, right? Once you finish executing the child function, you want to come back to the parent. So you points the parent activation record. Okay. Yeah, instruction modularity. And somebody wants to attempt these questions? Anybody wants to volunteer? No? No volunteers for this module? Okay. Okay. Which of the following are features of having higher modularity in programming? Increases code readability. Code is easy to understand and maintainability. Code is easy to modify. Increases code reusability. Same code can be reused without duplicating it. Increases effort in debugging. Identifying correcting efforts require more effort. Allows collaborative coding. Programmers from the organizations can be coding same program concurrently.
All are correct.
All are correct?
I mean,
All are
model.
correct?
How can
Sorry?
it help in debugging?
All are correct except C.
Yeah, okay, yeah, correct. Not in debug.
Yeah. So it says increases effort in debugging is what it says. When you
No, I'm
increases
sorry.
in-
I read it at decreases.
Okay, this one. This one, right? This is
Yes,
correct?
ma'am. Yes, ma'am.
Yes.
In top-down approach, complex task is broken down into subtasks. Is this correct?
Yes, ma'am.
Yes, correct.
Internal data representation should be accessible in data abstraction.
No, they are hidden.
False.
Correct.
False.
Data is hidden, right? The interfaces
Yeah.
are private is what? Sorry,
Yeah,
implementation
it's
is private.
private
is what?
code. Yeah,
Correct.
correct.
Hmm. Yeah, so how many people are not aware of queues and stacks? Does anybody need help with queues and stacks? I hope most people know, right? I guess you would have heard some introduction to this in CT, then Python. I think.
Yes, ma'am.
Are there any direct diploma people who need help with these concepts? Queue, stack, index. You can ask. Please don't have any inhibitions to ask because this is where.
Ma'am,
clarify.
can you explain DQs once?
Okay. Queues is actually C. So this is a stack, right?
Yes.
And this is a, sorry?
Ma'am, your screen is not visible.
Oh, sorry. What am I sharing now? Oh, I'm sharing the other one.
Portal.
Okay,
Ma'am,
okay,
you
sorry.
are sharing portal.
Okay, sorry, I'm sharing them. Is this visible now?
Now it's visible. Yes, ma'am, yes.
That's not. This is a queue, right? Something like this, no? So here what we'll do is we will insert from the top, right? And you will retrieve also from the top, right?
Yes, ma'am.
Here you will insert from the
Last.
retrieve from the front, right? Is this correct?
Yes, ma'am.
The DQ will have both the options. You can do both. That's the idea.
Okay, okay.
It will have all the 4 functions which are supported by stacks and queues. That's it.
Okay. Yes.
Share that. Okay. Okay. So which is the correct one here?
Option C.
Option C here. Okay.
C, ma'am.
Option C, right.
First in, first out. Stacks. Yeah, last in, first out, and C is insertion. Okay. Yeah. An object can be. Okay. An object can be what?
Can be integer, register, all of them.
All of them, right? Okay.
All of them.
Fine. Okay. Which among the following are okay? So somebody asked about the dynamic lookup, right? So again, I think I have to change the sharing. Just give me a second. Sorry about that. One second. See, suppose you have a class A. Okay, I explained the same thing in the last, like this thing, live session also. So just going by the same thing. Okay. So you have, say, void show. Now you have, say, class B. I'm going to use the terminology in Java so as to understand, but don't worry about these keywords and everything. I will tell you what these things mean later. Okay. Void show. Now you have a main class. Okay, you can put it as public. Don't worry about what these things mean. Okay. You have a main method. So this is a main method. There is a big syntax associated with the main method. And inside main method, you're going to declare two variables. Okay. One is say A. Sorry. Now, the Java code has to decide which. So you have two show methods here, right? Class A has a show method, and class B, which is extending A, which means that class B also has access to show. That's all for what you have to understand for now. Class B also has access to the show method, and you have a show method inside this class B also. Now you're declaring two objects of one of class B, the other of class A, and then you are invoking these functions A.show and B.show. At this point, the runtime environment has to decide which function to invoke. In the case of A.show, it is very clear because A does not know about the existence of B at all. So in the case of A.show, it is very clear which function to, once again. Okay, if I explain that, it'll be confusing. I will explain first what B does. Okay, so when I say B.show, right? In the case of B.show, you come here and it will invoke this B.show. Okay. Now, why? Because we know that B is this new object of B, right? But here, as you can see, A is an object of small a is an object of A pointing to an object of. So this is an object of A. It is pointing to an object of A. So even though we have said that this is new of B, this object A has access only to the function inside the class A, this function. Okay, so this will be determined during the runtime. And that is what is meant by dynamic lookup. So there are many, suppose there is a table, okay, which has this show method which corresponds to B, then show method corresponds to A, then there is another show method which corresponds to say C. And during the runtime, there is a lookup that is happening to this table to check which is the show method which is accessible for this object. And during runtime, it decides that, okay, this is even though this is an object of this, this is actually referring to, there's an object of A referring to an object of B. The A has access only for the show method inside the class A. This method, not the show method inside class B. Whereas for class B, sorry, object B, this one, right? It has access to both methods, but it will be invoking the method of this B. This is what is known as the dynamic lookup. Dynamic, the word
So,
indicates that, yeah.
This is the kind of, it is like inheritance, right? We are using inheritance.
Yeah, extends is inheritance, correct.
And then we are just saying that this B will be acting as for both the classes, right? The other B, if I'm not wrong.
No, I didn't understand. What is it? Which small b or capital B?
So I'm saying, see, the class B, the capital class B, is inheriting from the class A, right?
Correct.
And over here, when we are saying about when we are calling the function B, like B, small b is equal to new b. It's basically we are calling the function B,
This
right?
one.
Yeah, in the main class, correct? So
Yeah.
it will. So when I call the small b, I'll be getting the results from both the classes A and B, correct?
No, actually, see what happens. This is actually this is you call this as overriding. Okay. Have you heard of overriding?
Yes, correct.
Yeah, so I don't, yeah, so if I tell you all those things, then I think it will be a little bit of confusion. But what happens here is now inside this one, from an object of this B, right? Only this method is accessible. This method has been overridden inside that. So class B has access only to this method now. Whenever we say B dot show, sorry.
That means both are not visible, right? Both are not accessible. Only
No,
the
if
this
the
one.
show was not here, then this would have accessed this method.
Yes, only one of them at a time, not both, right? In either case, both cannot be accessible.
Yeah, because it has been overridden here, right?
Right. So it's
Yeah.
like a default function that if I don't overwrite it, it'll take the parent as the default.
Correct. So that will happen during the runtime is what you say. This association, right? Which function to invoke, that decision is taken up during the runtime. Am I confusing?
Okay, so you are saying that I can override the function at runtime. I don't have to choose it before. Depending on the value of something, I can change class B's function of show. Should I override or not at runtime?
No. This overriding has happened during, compilation. We have already written it inside.
Then how do we decide it at runtime then? Which one will run?
No, I did not understand. What is it? Sorry. The overriding, see, this declaration has happened inside.
Right. So now class
So
B
with
only.
yeah. Sorry.
So I can't switch. How do I switch to the other one? If I want to run the parents function for B, I can't do that now at runtime. If I want, like for the object B, can I still run a.show? No, right?
Oh, no. So which B are you talking about? Small b, is it?
Yeah, the small
Object
b.
of B.
Yeah, the
Small b,
object.
can it run the capital show is what you're
Yes.
asking.
How is the dynamic lookup happening here? That how do I have a choice that dynamically I can choose or look up?
No, you are not choosing. See, you are not choosing. It's the runtime environment which is choosing. Programmer is not choosing. The runtime environment has to decide which show method to invoke. That is the dynamicity there.
Okay, so dynamicity means that I can
It's not the
override.
programmers. Yeah, so just 1 second, I will check it. Are you on call?
Yeah. I
you
think
want-
I got what he's telling. See, like we are having two version of shows, right? Like show function. So one belongs to the parent and one belongs to the child, right? So now whenever I'm calling any of this, I need to call, right? So
But
now
that is dependent on the object, sir. That is not dependent in.
yeah, I'm
It's
telling
not
that I have to call any of this version, right? So which version will be called, that decided on the runtime exactly which type of object you are referring to, right? So it's clearly if you refer to a parent type object, right? If you refer to a parent type object, see, if you look at this declaration, capital B equal to B assigned to new B. So you have to understand the small b is basically a reference. It's a variable which is created somewhere on the stack, right? And your object is somewhere created on the heap where it is referring to. Now it is not the type of the variable. It's not the type of the reference who determines which version of the function will be called. It's basically which type of object you are referring on the heap. Depends on that. Actually, that dispatcher decides like which version of the show has to be called.
Okay,
Am
for
I
me,
clearly? Yeah.
it seems like a simple template. I'm taking an object capital B, I mean the class capital B, and assigning it to small b. So I
Yeah.
will inherit, my object will be same as whatever class capital B is. How is it
I'm
dynamic?
telling, see, I'm clearly saying, if you look at the first statement, capital B, small b, assigned to new B constructor, right? So what is happening? This small b is a variable, right? Which is a reference, which is referring to a memory which is created on the heap, right?
Yeah.
So now on the heap, which kind of object you have? Your object type is B, right?
Yeah.
So small b referring to a capital B object. So if
Right.
I call it through the small b here, so definitely the call of the version, that show function version will be called which belongs to the capital B. But if you move to the next line, the small a, what is the type of small a? It's the capital A, right? But what type of object it is pointing to? It is pointing to an object. It's referring to an object which is of capital B. So what is important? Which kind of object you are referring to, not the type of the variable. So since on the second line, although the reference is of type of capital A, but object is of type of capital B, it will call it from the version B.
Okay.
So that's why the term dynamic comes. So on the runtime, it finds out which kind of object actually you are referring to. Yeah.
My style will be showing as A, but the properties will be that of B.
Yeah, that's the dynamic runtime nature, right?
Okay, so you are saying that at coding time I can choose a certain type, but assign it a different set of capability by using a different type.
Capability you can assign, but you are not free to do everything. So there is something called as a dynamic method dispatcher. I think it will be there after some time. We'll discuss that. So there you can understand which thing you can refer actually, right? You cannot refer all kinds of objects. So the rule is like you can refer to your own objects or child object. Other things you cannot refer. So if you go as per the rule, you can do this.
Okay.
Yeah,
All right. I'll try this out.
Yeah, so Arup, just adding, like, there are two definitions for the show method. When the runtime environment, whichever is executing this, when it reaches here, it has to have a lookup. It has to check. At that point, it has to decide which show method has to be added to the activation record and executed. That is the dynamic thing. That is the dynamic lookup. That's it.
Hello, ma'am.
Created, that is already done when the object is created. It will not be dynamic after it's created. It cannot change, right? So once it's created,
No,
and
see,
assigned,
it is created. The function definition is all there, but what has to be executed is deciding during runtime, right? See, it can execute either show. There are two versions of show, right? So which has to be executed is decided during the runtime, right?
Okay. All right, ma'am. I'll try this. Sure.
Yeah. Who is that? Sorry, somebody else is asking something.
Yes, ma'am. I'm asking that in this example, the last two line A dot show and B dot show, the small a b. So, is that show referring to the child one, capital B dot show?
This show.
Yes, the small a dot show and small b dot show.
Yeah, small a dot show will actually refer to this one, and small b dot show will refer to this one. So see, what I would suggest to you is like these things, let us go to Java. Then all that now you have to understand is that there are multiple definitions for the same function inside a program, right? So how do you do that in like other languages? You cannot have the same function inside same functions with different names. No, it's not possible, right? Here you have functions with different names, albeit inside different classes. So whatever function has to be called is for now, please understand that this choice is made during runtime by the runtime environment. And when we come to that portion in Java, I think it will become more clear for you. When you write more programs, when you try and experiment with more variables and everything, you will probably understand it better. Now that it is all, like at least people who do not have exposure to Java, I think it will be quite easy. So for now, please understand that during runtime, there is a decision, certain decision taken as to which function is to be invoked, and this is the dynamic lookup.
Just one question. Instead of
Sorry?
putting new B, if we write the new A and take a and we are putting X, then X should show also directly referring to the class, right?
Sorry, I missed a few things you said. What is that? Can you come
Suppose
again?
I'm again declaring capital A, small x equals to new A and a function call. And I'm putting X dot so. It is going to refer that A dot so, right? Means upper so, right?
You mean A X equal to new B, is it?
New B not A.
New A.
Yeah.
Yeah, then X dot show is like very clear.
It's
A
like
does not. Sorry?
So, yeah. So what it will show, this X dot so will be show the upper one, right?
The first one, top one.
So now question is why we need to declare like this A capital A small b equals to new b. What is the advantage?
So no, this is not capital B, this is small A. Okay?
Small A, right?
Yeah, A equal to new B is what you're saying, right?
Yeah, right. So what is the advantage when we
Yeah,
call?
so that you will come to know. See, there may be, say, something, for instance, say class, some electronic device, okay? Device, okay? And then the electronic device can be a computer, it can be a printer, it can be a scanner, all these things, okay? And then you write all these functions inside, and then you say, okay, your computer, you want your this thing to do whatever, okay? So you will try to understand like what is the advantage of using, sorry, not printer, computer, this should be electronic device. At multiple levels, what is that advantage of using that you will come to know. Okay, there is an advantage that you will come to know. Okay. There are a number of times when we use this actually.
Something like function overloading, right? The same function, different functionality. Right?
The function overloading is different. Function overloading is the same function will have different parameters. No? That is function overloading. Overloading and overriding is different.
So which one you're calling? It's not clear. Like, can you tell me like which one you're asking for?
I'm asking this capital.
He's asking what is the advantage of this.
Okay, okay. See, like what you have discussed last day. You were there in the class?
No, last time I was unable to.
Okay, last day we have discussed like the memory allocations, right? So there were two things. Whenever we do a local declarations or local definition of a variable, it stays on a stack, right? It goes into an activation record. And whenever we do some kind of dynamic memory allocation, it happens from the heap. And we have also discussed that any allocation which happens from the heap, it's a unnamed allocations. Means whenever I say, suppose a int a equal to 10 in simple way, integer a equal to 10, we know a is a named memory. The memory name is a, where I get the value 10. So it is easy to refer a to get 10. Does it make sense?
Yeah, I'm getting it.
But the thing is, if I have a memory which doesn't have a name, how do I refer to that memory? That's a problematic part, right?
Right.
So that's why this syntax is. See, right hand side, the new, if you look at the new in Java is a operator which do the dynamic memory allocation, right? So a memory, chunk of memory is allocated on the heap, right? So what will be the size of the memory? That depends on the which kind of class we are going to instantiate. The size of the class for which you are going to create the object. And this B open close bracket, this calls a constructor. It says what kind of values will be stored inside the chunk of the memory. So memory is created on the heap. It is initialized. The values are stored into it. But the question is it's unnamed. How do I refer to that memory which I have created on the heap? Up to this, is it clear?
Right, clear.
So that's why the left hand side comes. Now I say I'm having a variable a which will store the location where this memory is created, right? So to refer to this memory, what I'll do, I'll call a. So a means it will give me the location where this memory chunk is created. Now is it clear?
Yeah, okay. Thank you.
Thank you.
Arup sir, just follow up. Can I ask something quickly?
Yeah, please.
Shouldn't this then the constructor be a lowercase a is equal to new a?
See, it again depends on, I got your point. You're telling that class name on the left side it's a, right side it's a b. It's
left
possible. Yeah, Punit, I got your question. Normally it's a equal to new of a, but it's possible.
The object type, then the object should change, not the left
No,
side.
no, no. I'm telling you. Just now, a few minutes before, I told that the type of reference and type of object, right? So on the left hand side, the type you have, and the right hand side, your object you have. So they may be of different type. Normally, they are of the same type. They can be of different type if you are having a property of inheritance that's B is inherited from A. So any reference can refer to a object which is of the child type. So since in this figure you can see B is inheriting A, so A can points to an object of B. So A can points to object of A also. A can also points to the object of B. Now if you look at the B, class B can points to object of B, but it is not possible B will refer to an object of A. That time it is a error, right?
Yeah, but yes, yeah, it says B extends A. So that's why I'm saying the type B is anyway saying it extends A.
Can you go back to our subtype concept? See, whenever you are
uh,
saying B is a subtype of A, B
I
is
will
a
show you.
subtype.
Can we then skip this, do it on discourse? Let's carry on with the session.
I'm not getting you.
Sorry.
We can carry on this discussion about this on discourse. We can
Okay,
carry on.
okay. Yeah, please. Okay, thank you. Yeah, please. Yeah, Dhanya, please go on. Thank you.
Yeah. Okay, so let's stop sharing this here. I'll share the code. Just give me a second. I'll share that. 1 second. Yeah. So which among the following are features of object-oriented programming language? So dynamic lookup, as I told you, right? It is because it's of two different objects, right? A and B, right? So two different objects, but referring to an object of the same type. So that's when this dynamic lookup property is applicable, and hence it's a feature of the object-oriented programming languages. Okay. Abstraction, clearly I have explained abstraction, subtyping, and inheritance we discussed last time. There was still some confusion about subtyping and inheritance, but I guess as Arup finished in the last session, like Java, these are both tied together. These concepts are tied together. So when it comes to the Java specific concepts of subtyping and inheritance, will be very clear, and this kind of confusion will not exist. Okay. So I have seen, so there are so many posts also on Discord. So I think one of those posts had some confusion. So I don't know whether they have replaced it. Let's see, the students had pointed out there was one mistake in one of the posts. So I hope so whoever I put it will correct it and do that. So that was this one. Okay. Which of the following statements is correct about dynamic lookup? It's the same as method overloading. It tells whether data member can be accessed on an object. It tells us a choice of method implementation at runtime. Reuse of implementation is possible because of dynamic lookup. This is the answer, right? Anybody has any confusion on this? We just try to understand this for now. Whatever is Java specific, we will come to it in the when actually we start with Java in the next video. Okay. Which of the following statements are correct about subtyping? Subtyping is same as inheritance. If A is a subtype of B, then A is a specialization of B. If A can be implemented using B, then A must be a subtype of B. Anybody wants to answer this question? Is subtyping same as inheritance? Sorry, who is speaking?
No, subtyping.
Rakesh, your voice is. Rakesh, can you speak again? Your voice was not audible.
I'm saying that the answer should be option B and D.
B and D, yeah? Correct,
yes,
no?
yes.
Yeah. Does anyone have any doubt on this? Subtyping is definitely not same as inheritance. If A says subtype, then A is a specialization. We said that whatever are the features of B, that A will also have, it will have additional features also. It can be implemented using B, then A must be a subtype, which is not necessary. Okay, match the following. Stack in queue. What does stack in supports? Insert, friend, and delete friend. What does inherit from dict? Subtype of stacking. So dict, we have seen is a subtype of stacking queue. So B is 4. So one of these three options. Then stack supports insert friend and delete friend, which is correct. So C1. So the option, then D, 2 or 3. Okay, so now we'll go to the classes and objects. So in object-oriented programming languages, object is determined by its
Class.
sorry.
Class.
Is it correct? Yeah. Okay, so why is object determined by its class? What is the relationship between class and its object?
An object is a subclass of main class.
No, that's not
Object is a
correct.
class type variable.
It's an instance of a class.
Yeah. So I would say a combination of both the second and third answers. See, it's not a subtype or a subclass. Okay, so it's more like a class is nothing but you are saying, okay, this has to have this variable and this will have this behavior. Okay. Whereas in the case of object, it is actually an example or an instance or something with these muscles and flesh and everything, right? Earlier class is a template or a skeleton. Here you are adding everything. So variable means it will have actual value. The variable is actually now a memory location which is pointing to some data. And then when you are invoking a method inside the method of an object, that method actually gets executed. Right? That actually defines the behavior of the object. Whatever are the permitted behaviors of that object is actually given by the class definition. So this is a relationship between class and object. You have a class which is something like a template, something like, you have this, what do you call it? There are certain, the clay modeling, you use certain templates. You fill the clay and then you get the finished product. So
Yes,
that
ma'am,
base, a mold, sorry, I'm searching for that word. Thanks, yeah. So the mold is something, the class is something like the mold. No, don't just compare word to word and whatever I'm saying, just giving you an analogy so that you can appreciate it. Okay, so mold is something like that. What you are expecting from, if you create an object from this, how will it look like? That is what is the class means. It's a template. Now, once you create a mold, that is an actual object, right? That is what is an object is. Okay. So that's an object and a class. Which of the following statements is true about inheritance? According to inheritance, we can reuse the functionality of one object to define at most one another object. According to inheritance, we can use the functionality of one object to define any number of objects. Inheritance, a relationship of interfaces. Inheritance, a relationship of implementations. What is a relationship of interfaces? Which is a relationship of interfaces? Which is a relationship? We discussed last time. Sorry, subtype. So in your inheritance, a relationship of what?
Implementation.
Implementations, correct. Yes. And this is for
And
any number of objects, right? Not just one. We are not specifying, we are not restricting, it's only for one particular type or anything. We can inherit for any number of objects.
Ma'am, I have confusion regarding the second option. So like, so in inheritance, like we inherit one class, like a class gets inherited, but like now we are here talking about the objects. So like I am a little confused regarding that. Like when we are inheriting classes, then how objects are being used from one object to other objects are. Like the option is, according to inheritance, we can reuse the functionality of one object to define any number of other objects.
So you mean to say that should have been a class instead of an object, is it? Is it what you mean?
Yeah.
According to inheritance, we can use the functionality of one class to define any number of other classes. Is that what you mean?
Yeah, right.
Functionality of one object to define. Okay, so that's a. Should we say that is a class or an object, right? That's your question. Okay, so.
Right.
Technically, class would be
more appropriate.
better. Yeah. But yeah, these cases like we use it like interchangeably
Interchangeably,
sometimes.
yeah,
Yeah, yeah.
that's what happened. Yeah,
Yeah,
that's
what
probably
you're
why we
saying,
didn't
it
even
makes a
notice.
sense definitely. Yeah.
Correct, yeah, correct. So we, because once you start using these things, you will start using it kind of interchangeably, right? Now that you are looking so focused with this class definition, object definition, everything, you are able to see the difference. At some point, this all becomes, interchangeable. So that's it. Okay. Yeah. What you said is right. That looks more appropriate. Consider a simple graphics program to draw different shapes like rectangle, circle, and triangle, which are the following features of object oriented. Can someone mute? There's a break. Shubham Kumar? No, someone's. Yeah, thanks. Okay. Consider a simple graphics program to draw different shapes like rectangle, circle, and triangle, which are the following features of object-oriented programming language is used to implement this program to perform same operation called draw on different shapes. So that I think we just discussed, right? It is not none of these. I mean, it's not any of abstraction, subtyping, and calculation. We define this draw inside each of these, and then during runtime, depending on which object is. Arup, is it because we described class B and A as
Yeah, I'm just
like B
checking.
being inheriting, B being inheriting A that caused confusion. So should we have explained something like class rectangle, inside there is a draw method, class circle, there is a draw method, class triangle, there is a draw method. So would it have been more clear about the dynamic lookup?
Yeah, you can do that, but conceptually it is the same.
Yeah, correct. So maybe, I think it was a little confusing because we said that one extends the other and then try to use the same method, right? That's probably, yeah. So see, here we are saying 3 independent classes. Okay, rectangle, circle, and triangle, each of which has a draw method. And then during runtime, depending on which object that is, which object dot draw is what we calling, that function gets invoked. And that's why that's also a dynamic. Okay. Which of the following statements is correct? Class is a template for a data type. A class is a concrete instance of a template, which is not correct. The instance variables of different objects of the same class will have the same value. Is this correct? The third one?
No.
Okay. So instance variables of different objects will have different value. Otherwise, it doesn't make sense to have the ability to create different objects of the same class, right? So it's not a class which is storing the value. Of course, there are variables in class which will store value. That's different. But in general, the objects which are class specific variables will have different value for different objects. Sending a message to an object refers to the process of asking an object to execute a function on itself. Okay. So this is clear, right? Class is a concrete instance of a template is wrong. Which is a concrete instance of a template?
Object.
Object is instance, right? Okay. Sending a message to an object refers to the process of asking an object to execute a function on itself. So for instance, you are creating an object of say rectangle inside the rectangle itself and then execute a method function on itself. Say for instance, so is this clear? Do you want me to explain like this is process of asking an object to execute a function on itself? How do I show this? Okay, so that should I let me just share this and show you. So you have say class point, okay, and you have say in x comma y, and you have say a function public find sum also. And then creating a point say p P dot find sum. You're actually using an object to invoke a function inside the class, right? This is the just sending the message. It's very simple idea. Only thing when it involves words like sending message and all that, it becomes very confusing. That's it. Asking an object to execute a function on itself. Okay. Okay, so does anyone want to attempt these questions? Which are the following statements is there are true about the type of a variable? Does anyone want to try it?
It's B and D.
Sorry?
It's B and D in Python. Whatever
B and D.
In Java, we need to declare it.
Python type of variable depends on the value assigned to it. Right stated type. Java type. Compile time itself. So in Python, can you not determine during compile time itself?
No, suppose you are assigning a number x equals to 2, and now later if define x equals to ABCD, then it becomes a string, right?
Okay. Got it. Yeah. Okay. For dynamic lookup, dynamic means different objects respond in the same way to the same message. Dynamic lookup means different objects respond in different ways to the same message. Dynamic lookup means same object responds to in different ways to the same message. What does this? What is the correct answer? We just saw the example of dynamic lookup, no? And where what are we using the different objects? Same message or same object, different message? Sorry, same object, same message. Sorry, yeah.
Different ways to same message. Option B.
This one, right? Yes. There we had the same message, which is the function dot show function, right? And then we had two different objects, no? So different objects respond in different ways to the same message. Let me just check the answers. Okay, I'll check at the end. So you will understand the wrong thing, and that's not. Okay. So different objects respond in different ways to the same message. Okay. Which of the following features an object-oriented programming language hides implementation details?
Abstraction.
Right. That's correct. Then suppose A and B are two objects. Is that object A has all the functionalities of object B along with some extra functionalities? Then which of the following statements is or are true? Yeah. Nivedita, do you want to guess? Take your time to read. You can make object A as a type of object B.
Ma'am, C.
This one. You can make a object A. All the function. And use object A. Yeah.
Right. It's correct.
Sorry?
No, correct. It's correct.
Which among the following statements is true about writing programs in low-level languages and high-level languages? Writing a program in a low-level language is error-prone. Yeah, anybody wants to guess? Okay. Not guess. Anybody wants to attempt? Yeah, sorry. Yeah.
First one is correct because writing a low-level program, it's error-prone.
Why? Why is that so?
Because we need to write in the bits and the register.
Correct.
It's very difficult to write, and we need to write a bit of them.
Yeah, we can understand English better than the binary, right? Zeros and sequences, zeros and ones. Yeah. It's easier for us to process that. Okay. Yeah.
I think option C is the correct. Program has more
code is mapped to the machine architecture when the code is written in a high-level language, which is not correct, no? See, what is closer to the machine architecture? Is it the high-level language or the machine code?
The machine code low-level language. So
machine code is more close to the computer, the machine architecture. As I told you, right? for the same function, say for adding two numbers, one particular computer architecture will have some sequence of zeros and ones, and another computer architecture will have a different sequence of zeros and ones. So when you are writing it in the binary code, it is more mapped to the machine architecture, right?
Yes.
But a programmer has more control over how a code is mapped to machine architecture, and the code is written in high-level language. Okay, so if it's about the programmer's control over how a code is mapped, then it should be a high-level language.
No, sorry, it's not correct, because you are writing in high level, then you should have a correct mapping of low level. Then only you can able to map it. That's why this option I think
So
not
that's
correct.
right. But I was also a little confused with has more control over, right? Has more control happens with the high-level language only, but then the machine architecture part is the wrong. Okay. Language translators like compilers and interpreters are required to convert a program in a high-level language to a low level. This is very clear. Which among the following statements are true about imperative and declarative? An imperative program focuses on what the output is, and output is related to the input. Okay, anybody wants to try this rather than me speaking and reading it?
The first one is wrong.
What the output is? Correct. That's correct. That's wrong. What you said is correct.
B is correct.
What's the consideration that I said? Correct. That's correct. Yeah.
C is also correct.
Yeah. Declarative program will totally avoid using intermediate variables, right?
Yes, ma'am.
Then how about D?
No, ma'am, it's wrong. It's about
The inductive structure is generally for the declarative programs, right? The recursive thing that we saw. Yeah.
Just one question. In declare program, we can tell if it is a recursive return, most of the programs are in a declarative program.
Sorry?
If it is a recursive program, we can say recursion. Okay. So that all are considered as a declarative program because we are not using any intermediate variable directly. It's doing inside automatically.
No, I don't think we can generalize it to every recursive program, but very simple recursive programs which do not, which do not have any intermediate steps on achieving, right? So, see certain dynamic programming algorithms, which uses recursive implementation. Some of them might use intermediate variables and all that. So we cannot. I don't think we can generalize it, but all the simple programs that we have discussed, we can say that they are.
Yeah, I'm talking about the simple only, not all.
Yeah, that's correct. That's correct. Yes.
Okay.
Yeah, because this inductive structure, right? That's what is meant by that inductive structure. Which of the following statements is not true about variables? Yeah, anybody wants to answer this?
Ma'am, B and D.
This is correct. Statically and dynamically created data is stored on C and sorry, which is the correct one?
B and D.
D is it? Okay, during this is wrong anyway. That's why dynamic data is okay. During the lifetime of period, there may be times and that this is also correct. Variable can be static. It is only correct. You're right. Right. Yeah. Anybody wants to try this?
Here animal has walk method and bird has walk and fly both because it is inheriting. So animal as fly will be not valid.
Sorry, animal has fly is not
Animal
valid.
Has,
fly
yes,
is not
yes,
valid. This one is not valid, right?
Yes, yes.
The option B is not valid, correct?
Yes, ma'am.
Oh, you are right. Choose the correct memory mapping for the following pseudocode. So this is a bit like, you have to go through the stack for each value and see that. Does anyone have, okay, if you have doubt, we'll go through one after the other. Otherwise, can you just work it out on your own? Or do you want to try it now? Does anyone want to try it now? So this is okay. If n equal to 0, return, okay, what it does is mode of 10 and element of element sum. So it first called for element n, then element n was numbers. So does anyone want to try this? Can you please tell me? Anybody wants to try this? Sorry. So you clearly have what is the starting value? So you're starting off with 12, right? So this will have ones, mode n, so mode 10. Just I don't remember this question. So Nalini, do you want to help me with this question? I don't remember how we did this. Are you on call, Nalini?
Yeah, yes.
Do you remember this question? Yeah, can you explain this? Yeah.
Yeah. Just can you go to the question once?
Yeah.
Okay. So this is actually recursive function call, right? Element sum.
Yeah, recursive call, and the function is being called here. The first time it goes, this is element sum of 12.
So n is not equal to 0, so that will goes to the else part.
Correct.
So percentage.
Yeah.
2, remainder is 2 plus element sum. Again, the same method will be called, but this time, yeah.
So just one second. So element sum. Okay, yeah, carry on. Sorry. Yeah. Second time.
Yeah, second time it will be called, but with n. Previously n is 12, right, ma'am? In the first.
Correct. Yeah, correct.
Step 12 is divided by 10. Right. Yeah, but this is like integer division in Python. Like if we use as double slash, then it will give integer division. So 12 divided by 10 is like
1.
Yeah.
Yeah. So this again. Yeah. Now first is over, and now second time we are going.
Again, it is not 0. Yeah.
Yeah, this is not 0. So again we report here. So 1 divided by 10 is now it will be 0. So 3 function calls.
Yeah. So here you have 1. So there should be at least 3 activation records, right? Yeah. You have 1 here, 2 here, and 3 here.
Okay. And the only thing is like we should know like where the control link and the return value link is pointing to. So first for n equal to 12, that is our starting thing. And n equal to 1 is the next thing, and equal to 0 is the next function call. The control link will point to the previous activation record, no?
Yeah, so here this one is wrong, right? This one, the control link is pointing to the wrong one, correct?
Yeah.
Control link has to point to the storage for elements. Right?
Yeah, yes, yeah. The control link should point to the beginning of the previous activation record. That is not happening in the first option. Yes, ma'am. Second option. Yeah.
The second option, same thing. The control link is not pointing to the.
Yes, yeah, yes.
Yeah.
Yeah.
Third one, control link is pointing to this one, and return value link is pointing here. So it's only with respect to the control link that you have a problem with the first two, right?
Yeah.
Here again, the control link is the problem. Okay, so I got it here. I'm sorry about that. I kind of forgot what was happening. Yeah. Thanks for helping me. Yeah, so those who have not understood, do you want me to explain? I'm sorry, I messed it up. So so what happens is element of, you're calling it by 12 first, and 12 is not equal to 0. So inside this is an integer division. So it divides you, the value is 1. And that is actually adding another activation record, which is the second one. And when it comes here again, it will check if n equal to 0, which is not true. So again, one more activation records get added. So eventually you will have 3 activation records for sure. Now you want to see whether the control links and the return links are pointing to the correct location. Here, as you can see, the control link is pointing to the element sum. It should actually point to the storage for, I don't know whether you can see my mouse, but the third activation record control link is pointing to the element sum rather than the storage for element sum. So that is a mistake there. Here again, the control link is pointing to the same thing. For this one, the control link is pointing to the activation or the parent activation record. So this is the last. So here this is the top of the stack. The third one is the top of the stack, and from here it is pointing the control link of the parent activation record. Here also the control link is wrong. Okay. Okay. Yeah. So this one, somebody had a doubt on this question. Do they still have the problem?
Yes, ma'am. Can you explain this question?
So in general, Python does not support overloading. No? Does it support overloading? So what happens is here you have one definition of area, right? And the next time it looks at, see, it's an interpreter, right? It looks at this, it looks at this, then it looks at this, then it looks at this. Then when it sees this, the latest definition of area function is this one, right? The latest function of definition of area function takes in 2 parameters. Whereas this function call is actually having only 1 parameter, right? So it gives a compiler error. The code generates an error.
Ma'am, this is overloading or overriding.
So as
in this example,
no, there is no overloading or overriding happening. There is no overloading happening. In fact, in Python, what happens is it is line by line execution, right? So this is done. This is done. Okay. Now here, if you had printed print area of 7, that would have worked.
Okay, got it.
Here you are writing, then you have a new definition of area, which takes in 2 parameters.
The latest declaration.
Correct. Latest definition of area function. Yeah. Okay, so that was the problem with that. Then you have incorrect characteristics about abstract data types. Okay. Yeah. Which are the incorrect characteristics? So we said that it has a fixed interface. Is correct. Structured data collection. Implementation is not correct. Implementation it should not have the interface. Is this clear? Interface, I said that the other day it's about the data, right? So you can keep changing. Sorry.
What is fixed implementation?
So implementation is a public implementation, right? So 1 second. Implementation is a behavior, no?
No, what is fixed in that? It is said fixed
You are
implementation.
not going to change it. Fixed means the implementation will remain same. Only the interface will change, or interface will remain the same. Implementation will change in that way.
Okay.
See, if you have, say, something like sorting algorithm, okay, someday you have you have done an automation of a school system and you are sorting the students list by their roll number or something. Inside that, you can actually change how you want to do the sorting. One day you can use a quick sort, one day, the other day you can use a merge sort, whatever. So that implementation can be changed, but it should be changed in such a way that it does not affect the how the user perceives it. The user should not see any difference in how the sorting is done. Internally, the code might be a quick sort or a merge sort or a bubble sort or whatever. That is implementation that can change. The interface which the user sees, like I just need to sort the roll numbers. I don't know how it is being done by the system. So it should not affect the interface with the user. That is a got it.
That is the fixed interface where the implementation gets changed either by short.
No, these are all, see, I'm saying like these are all correct values. The incorrect one is fixed implementation only.
Okay.
You are asking for the incorrect characteristics, right? Sorry, I chose only the correct ones. So answer is asking for the incorrect characteristics.
Okay.
The implementation need not be fixed. That's what it means. Okay. Okay. A be an object of waypoint, B be an object of two-wheeler. What is the output of B dot display? What is the answer for this? B dot display.
Ma'am, D, option D.
D.
D,
This
D.
one? This
Yes,
one?
ma'am.
Why?
Yes, ma'am.
Why is that so?
Ma'am, because we are calling the function by B and B
Yeah,
is a
B is an
subtype.
object of two-wheeler, right?
Yes,
No,
ma'am.
there is no A be an object. No, there is no subtype or anything here. No, we are just saying we are not
ma'am,
defining any subtypes. No?
Okay, ma'am. So just because B is calling the function, we are
Yeah,
printing.
that's it, right? B is an object of two-wheeler and B. Oh, okay. Oh, it's a subtype. Sorry. I missed it. Sorry. Got it. Sorry. Yeah. I know what you mean. Okay, sorry. Got it. Got it. Yeah. This is because even though it is this thing, but this method is inside this. I'm sorry. Okay. Okay, fine. Yeah, sure. So that is the end of practice assignment questions as well. So as I understand, the deadline with the graded assignment has been extended, no? Has it been?
Yes, ma'am.
It's been
15th of
extended.
May.
Okay. Okay. So if anybody has any other questions, please ask. Otherwise, we'll wind up the session. Okay.
Hello, ma'am.
Yeah, Rakesh.
One small question
Yeah.
about the activation record. That when a new record is created, is it only when a new function is called, or there may be any other criteria?
So an active, it may not be an entirely new function. It could be a function call of the same function. It's a new function call.
Okay, new function call. Okay.
Yeah. So see, suppose you have say function. Okay, I'll give an example here. So you have main. Okay, why would I write it here? Say I have a main function here. Okay. Inside which I'm calling say F1. Sorry, F1, I'm calling F2. Then I'm calling F2. Okay. Now I'm calling F1 again. So every time I call this, there is something new get added. Suppose there is an F1 inside this. So you have main. Main gets called here, right? Then you have say F1. Yeah, you calling F1. Okay. F1 is getting executed and then you are removing F1. Okay. Once F1 comes out of this and it goes here, F2 gets added here. Okay. This is F2. Okay. Now F1 is removed from the stack. F2 is. And F2 is calling what? Once again, F2 is calling F1. So F1 is actually added to the stack because F1 is inside the call making a call. No? So again, F2 is getting added. Now if this F1 finishes, it goes out. This F2 finishes, it goes out. Once again, the F1 is added here because of this function called F1. Okay, so for every function call is when an activation record gets added. Depending on however nested the call is, right? Depending on that, more and more activation records will get added here, depending on the number of nested levels. This means from inside this, this is being called, from inside this, this is being called, from inside this, this is being called. Got it, no, Rakesh?
Yes, ma'am, it's clear.
Oh. Any other questions? Okay. Okay, so Arup and Nalini, we shall wind up, right?
Yeah,
No.
yes.
Yeah, sure. Okay. Thanks, everyone. Thank you. Okay. Yeah.
Good session. Thanks a lot.
Thank you.
Yeah, thanks.
Thank you.
Thank you.
Thank you, sir. Thank you, ma'am.
Bye. Thank you.